So let's take a look at this example together. So we're given X and Y values in a table. And so you can look over the data. And then from that data, they said, okay, this is the model that fits the data. Okay. And it's a nonlinear regression because a linear regression, if we remember, would be something in the form y equals mx plus b. So this is not in that form because our x is in the denominator, so it's actually a rational function. Okay, so it's not linear. So what they did was, for this example, the first thing we would have to do is draw a scatter diagram of the data and then sketch the fitted model on the same set of axes. So these points here are the points that come from the table of values up top. Okay, so this table of values turned into all of those points. Then, using the calculator, we can type in this equation and get points to then sketch that to show where that goes. Okay, so remember, in the y equals, we can type in 2.482 divided by x minus 2.904, and then we can hit second graph, and that will give us a table of values, which we can then use to get the points for that curve. So from here, we need to calculate the residual of each data point. So you can use your graphing calculator to do this. So the easiest way to do it is to use the stat edit option of your calculator. So in L1, I've entered in the X values, and in L2, I've entered in the Y values. So L1 and L2. And then for L3, what I'm going to do is I'm going to type in the given model. And I'm going to say, okay, so here's the model. So remember, the model was y equals 2.482 divided by x minus 2.904. So you'll see, instead of the x, I told the calculator, okay, instead of x, use L1. So once I do that and press enter, it'll fill in this entire column of data for me. Okay, so in order to make it do that, when I type it in, I have to have this L3 part highlighted. So you can see down here it says L3 equals, and you can see that up here I have it highlighted in black. That's the part of the calculator where you want this equation typed in. And then once you hit enter, it'll do this. So I would like you to pause the video right now and enter this data in L1 and L2. In L3 at the heading, type in this formula and hit enter, and make sure your data values in L3 match what I have in L3, and then resume the video. Now that you've taken the time to make sure those numbers match, the next thing we do is we move over to L4. So now remember, we have to subtract, and remember, it's the original minus the model. Well, my original y values are in L2. My model y values are in L3 because we just had the calculator find those for us. So now what we do is we highlight up here where it's in black, L4, and we tell it to subtract for us. We tell it, okay, go ahead and subtract for me. Do L2 minus L3. And then when you press enter, it fills this whole column of data. So at this point, I would like you to pause the video and just do this calculation to make sure that your numbers match my numbers. Now from here, we can calculate the sum of the squared residuals. So in your calculator, you're going to do stat calc one variable stats, which we've done before. We did this when we were finding the mean and the mode and the Q1 and Q3 and the median. All those are in one variable stats. But we're going to make sure that we tell it to do our one variable stats on L4, because that's the list that has our residuals in it. So once we have our residuals, we then tell it to do the one variable stats on L4, and then we want this value right here. So the notation here, that's sigma, so it means the sum, and then of the x's squared. Now remember, our values are now in L4, so what it's going to do is it's going to take all of those values in L4, it's going to add them up and square them. And that's exactly what we wanted. And so our sum of our squared residuals is 0.144, and that's rounded to 3 sig figs. Okay, remember IB 3 sig figs. So comment on how well the model fits the data. So we would say the model fits the data very well because the sum of squared residuals is small. And we know it's small because it's less than 1. Like if you think about it, this is a teeny tiny number. And if we look back up at the model, some of these points are really, really close or right on the model. So it makes sense that it would have a small sum of the squared residuals because the points are really close to the model. So your visual of, oh, look, these points are close to the model is now backed up by this data right here that the sum of the squared residuals is 0.144, which is a really tiny number, which means that all those distances, when we square them and add them together, they form a very tiny number.